find the neutral current in a single-phase residential system, firstly, measure the phase currents. Use a clamp meter to measure the current flowing through each phase wire. In a single-phase system, this typically involves measuring the current in each of the line wires. Record the measured values. Label them appropriately, such as IA, IB, and IC, where A, B, and C represent the different phases. Secondly, find the sum of the phase currents. Calculate the sum of the phase currents. The formula for this calculation is N equals IA plus IB plus IC, where N represents the sum of the phase currents which will be used to determine the neutral current. Thirdly, check if the sum is zero. In a balanced single-phase system, the sum of the phase current should theoretically be zero. Therefore, check if N, the sum you calculated, is close to zero. Use a tolerance value to determine how close to zero is acceptable. This can be expressed as the absolute value of N is less than the tolerance value. Fourthly, calculate the neutral current. If the sum of the phase currents is zero or within the acceptable tolerance, it signifies that the neutral current is also effectively zero. If the sum is not zero and exceeds the tolerance value, the absolute value of the difference represents the neutral current. The formula for this is N neutral equals the absolute value of N, where N neutral represents the neutral current. Understanding tolerance value is important. The tolerance value for the sum of the phase currents depends on factors such as the accuracy of the measuring equipment used and the specific load conditions within the electrical system. A typically acceptable tolerance value is often around 0.5 amps. If the calculated sum of the phase currents in is within plus or minus 0.5 amps of zero, the system is generally considered balanced, and the neutral current is considered negligible. If the value exceeds this tolerance, significant neutral current may be present, indicating an imbalance or potential issue within the system that warrants further investigation. When measuring phase currents with a clamp meter, ensure the meter is properly calibrated and suitable for the current range being measured. Select the appropriate current range and the meter to obtain the most accurate reading. Clamp the meter around each phase wire individually to measure the current flowing through it. Be careful not to clamp around multiple wires simultaneously, as this will provide an inaccurate reading. Accurately record the measured current values for each phase wire, noting the units such as amps. When calculating the sum of the phase currents, pay close attention to the signs or polarities of the measured values. In a balanced system, the phase current should ideally cancel each other out, resulting in a sum close to zero. If the phase currents have different signs, ensure they are properly accounted for in the summation. If the sum of the phase currents is not zero, it indicates an imbalance in the system. An imbalance can be caused by various factors, such as unequal loading on the phases, faulty equipment, or wiring issues. In such cases, further investigation is necessary to identify and address the cause of the imbalance. If the sum of the phase currents exceeds the tolerance value, the difference represents the neutral current. The neutral current is the current that flows through the neutral conductor in the system. A significant neutral current can indicate an overload or imbalance in the system, which can lead to overheating, voltage drop, and other problems. It is important to address any significant neutral currents promptly to ensure the safety and reliability of the electrical system. In a single-phase residential system, the neutral conductor serves as the return path for the current flowing through the phase conductors. The neutral conductor is typically grounded at the service entrance to provide a low impedance path for fault currents to return to the source, helping to protect against electric shock hazards. The size of the neutral conductor must be adequate to carry the expected neutral current. Electrical codes and standards specify the minimum size requirements for neutral conductors based on the size and type of the load being served. It is important to ensure that the neutral conductor is properly sized to prevent overheating and voltage drop. Regularly inspect the neutral conductor for signs of damage, corrosion, or loose connections. Address any issues promptly to maintain the integrity and safety of the electrical system. Keep in mind that the steps outlined above are general guidelines for finding the neutral current in a single-phase residential system. Always follow safe electrical practices and consult with a qualified electrician if you are unsure about any aspect of the process. Always to energize the circuit or equipment before performing any electrical work. Use appropriate personal protective equipment, such as gloves and eye protection, to prevent electric shock and other hazards. If you are not comfortable working with electricity, hire a qualified electrician to perform the work. Performing electrical work without proper training and experience can be dangerous and may violate electrical codes and regulations. Always follow all applicable electrical codes and regulations when working with electricity. These codes and regulations are designed to ensure the safety of people and property. Stay informed about the latest electrical codes and regulations in your area. If you have any questions or concerns about electrical safety, contact a qualified electrician or electrical inspector. They can provide you with expert advice and guidance to help you stay safe. Maintaining a balanced electrical system is essential for ensuring the safety and reliability of the electrical system. By following the steps outlined above, you can accurately determine the neutral current and identify any potential imbalances or issues. Addressing these issues promptly can help prevent problems such as overheating, voltage drop, and electric shock hazards. Always prioritize safety when working with electricity and consult with a qualified electrician if you have any questions or concerns. Remember to verify the accuracy of your measuring equipment by calibrating it regularly. A calibrated clamp meter will provide more accurate readings of the phase currents, leading to a more accurate determination of the neutral current. Additionally, consider the effects of harmonic currents on the neutral current. Harmonic currents are non-sinusoidal currents that can be generated by electronic devices such as computers, LED lighting, and variable frequency drives. These harmonic currents can add up in the neutral conductor, leading to a higher neutral current than expected. If harmonic currents are present in the system, it may be necessary to use specialized equipment or techniques to accurately measure the neutral current. Consider the load conditions within the electrical system. The load on each phase can vary depending on the time of day and the appliances or equipment that are in use. This can affect the balance of the system and the magnitude of the neutral current. Take measurements under different load conditions to get a more complete picture of the neutral current behavior. When investigating imbalances or high neutral currents, consider the possibility of ground faults. A ground fault occurs when current flows from a phase conductor to ground, bypassing the neutral conductor. Ground faults can cause significant neutral currents and can be dangerous. Use a ground fault locator to identify and address any ground faults in the system. Pay attention to the overall condition of the electrical system. Look for signs of damage, corrosion, or loose connections. These issues can contribute to imbalances and high neutral currents. Address any problems promptly to maintain the integrity and safety of the electrical system. Keep accurate records of all measurements and inspections. This information can be helpful for troubleshooting problems and tracking the performance of the electrical system over time. It can also be useful for demonstrating compliance with electrical codes and regulations. Regularly review the electrical system to ensure that it is operating safely and efficiently. This includes checking the neutral current, inspecting for signs of damage, and verifying that all components are in good working order. By following these best practices, you can ensure the safety and reliability of the electrical system. Keep in mind that electrical work can be dangerous, and it is always best to consult with a qualified electrician if you have any questions or concerns. Remember that the information provided here is for general guidance only and should not be considered a substitute for professional advice. Always consult with a qualified electrician or electrical engineer for specific recommendations and guidance related to your electrical system. By taking these precautions, you can help ensure the safety and reliability of your electrical system. This involves understanding the principles of electrical circuits, using appropriate measuring equipment, and following safe work practices. With proper training and experience, you can safely and effectively find the neutral current in a single-phase residential system. The neutral current in a single-phase system is the current that flows through the neutral conductor. The neutral conductor is the return path for the current that flows through the phase conductor. In a balanced single-phase system, the neutral current should be zero. This is because the current flowing through the phase conductor is equal to the current flowing through the neutral conductor, but in opposite directions. However, in an unbalanced single-phase system, the neutral current will not be zero. This is because the current flowing through the phase conductor is not equal to the current flowing through the neutral conductor. There are several factors that can cause an unbalanced single-phase system. One factor is an unequal load on the phase conductor. For example, if one side of the phase conductor is loaded with more appliances than the other side, the current flowing through the phase conductor will be greater on the loaded side than on the unloaded side. This will cause a neutral current to flow. Another factor that can cause an unbalanced single-phase system is a faulty appliance or wiring. For example, if an appliance has a short circuit to ground, the current flowing through the phase conductor will be greater than the current flowing through the neutral conductor. This will cause a neutral current to flow. A significant neutral current can be a sign of a problem with the electrical system. If you suspect that you have a significant neutral current, you should contact a qualified electrician to inspect your electrical system. There are several ways to reduce the neutral current in a single-phase system. One way is to balance the load on the phase conductor. This can be done by distributing appliances evenly between the two sides of the phase conductor. Another way to reduce the neutral current is to repair any faulty appliances or wiring. In addition to the above, here are some additional considerations. Firstly, check for loose connections. Loose connections can cause resistance in the circuit, which can lead to an unbalanced system and increase neutral current. Check all connections in the panel, receptacles, and light fixtures to ensure they are tight and secure. Secondly, consider the impact of nonlinear loads. Nonlinear loads, such as electronic devices and appliances with switching power supplies, can generate harmonic currents that contribute to neutral current. If you have a significant number of nonlinear loads, consider using harmonic filters to reduce the harmonic currents and the resulting neutral current. Thirdly, review the grounding system. A properly installed and maintained grounding system is essential for safety and for minimizing neutral current. Ensure that the grounding electrode system is properly installed and that all grounding connections are tight and secure. Fourthly, monitor the neutral current over time. Use a clamp meter to measure the neutral current at different times of day and under different load conditions. This will help you identify any patterns or trends in the neutral current and pinpoint potential problems. Fifthly, consult with a qualified electrician. If you are not comfortable working with electricity or if you are unsure about any aspect of the process, it is always best to consult with a qualified electrician. An electrician can help you identify and address any problems with your electrical system and ensure that it is operating safely and efficiently. Finding the neutral current in a single-phase system requires understanding how to measure phase currents, calculate their sum, and interpret the results with consideration for tolerance and potential imbalances. By following these steps and keeping safety in mind, one can effectively assess and maintain the integrity of the electrical system.